Hello friends, this is ML with AP. In last video we talked about Python basics, its origin, why it became popular. We also talked about Jupyter Notebook and Anaconda and why we should use it. Today we will discuss Python syntax and semantics. Now what is syntax and what is semantics? Let's first discuss that. Syntax. Syntax refers to the structure of the language. So how the language is written, it's syntax. And semantics, in very simple term, if I have to say, semantics is the meaning of the words which the language carries. Okay. So before we go to programming language, let's talk about the natural languages. So natural languages. Natural languages are like English, Hindi, and other languages. In English, when we say this is my computer, we put a dot or a period or a full stop over here. This is syntax. We use comma, we use apostrophe, we use semicolon, we use colon in various contexts. When we write a sentence, we start with the word letters, and then we form words, and then we form sentences, right? And these sentences becomes paragraphs, full stops. These are the syntax of the language. What is this which makes a language, right? The basic rule of the language. Now in case of programming, if you have to say, then if you are coming from any programming, let's say C background, then your braces, okay, when you start, when your code block, your keywords, how you start for loop, right, and how you indent a particular code block, all those things are syntax of that particular programming language. Now if you move on, then what is semantics then? What is semantics? Semantics is nothing but the meaning of those words. Meaning of words, right? So in case of natural language, let's say Hindi or English, in English, if you are writing a sentence, each of the letter, we'll go back to our example. This is my computer. Now each of these individual words, they are arranged in this order, but they all carry an individual meaning also. That is what is semantics is. So a computer program, any computer program is usually made up of syntax and semantics. In case of computer programming, computer programs, our semantics will be our variables, data types, various operators. Okay. So again, to give you the example of C, if you have to give C, then for the keywords, right, or how we or data types, int, float, right, or how we start a operator like greater than, equality, or less than symbol. These are our semantics. Okay. Now hope guys this definition is very much clear that what is semantics and what is syntax. Okay. One of the beauty of Python is that it's very readable. And if you ask me, this is one of the main reasons that why Python became popular. It's very clean and easy to read. It's almost like a pseudocode. It's almost like you are reading a plain English language, or you are reading a pseudocode written by someone. And that beauty is not incidental. The people who created Python very well knew that how to make it very, very easy and readable. Okay. Now, it is often much easier to read and understand a Python script than to read a similar script in any other language. And that makes Python so beautiful. We'll begin with discussing the main features of Python syntax. So before we jump into semantics, let's discuss syntax, and we'll be discussing Python syntax. Okay. Now let's jump into the Jupyter notebook so that we can see what we are talking about. Okay. Let's go to the notebook. Okay, this is my Jupyter notebook over here, friends. Okay, now this is the code which I have already written to save the time, but I will try to explain that when we say syntax, what it means. The first and the foremost thing which we should notice on the first line itself is, okay, there is something which is starting with hash or pound sign, and this is already highlighted. This looks like a comment. It is a comment. So comment in Python starts with hash or pound sign. Set the midpoint. So any comment. This is something which Python interpreter is going to ignore, and it will be treated as a comment. Okay. The next, we are defining a variable, and there is an equality sign. There is a spaces over here. We see that there are spaces over here, and there is a number over there. We also notice if you are coming from maybe a C-like background, then you can notice that we are defining or initializing a variable, but we are not doing something like I is equal to 5, and then we are not putting a semicolon. So semicolon is missing. In Python, semicolon is not necessary. It's just the end of the line is denoted by end of line. There is no special character for that. These white spaces, if you see, if you are coming from shell background, you will notice that these white spaces over there in shell, it is important, but over here, it doesn't matter. If you can increase the white spaces to this also, it will still read the same thing. It will mean the same thing to Python interpreter. Okay. Now, not all white spaces are redundant, and I will tell you just in a minute that why it is so. So let's guys, let's first understand that, okay, I'm defining a variable. There are white spaces. There is a equality operator. There is again white space. There is 5. There is no end of line syntax over here. End of line is represented by end of line. We make a again new line which is a blank. Again, these new lines can be ignored because the interpreter is going to ignore. The next line, we are again doing a comment over here. Okay, and the comment again will be ignored by the interpreter. Now it is not important to see. Now we'll be discussing that in the semantics and the various data types, but for now just try to understand that we are initializing two data types. These are list, empty list in Python, and it is denoted by a square bracket. So the reason why I put it over there is that I wanted to show that what this semicolon in Python means. Semicolon in Python means that you are putting two lines, or you are telling the interpreter that, hey, I'm putting two lines in one line. Run it one by one. That's all it is meaning. So if I have to put semicolon, the other way I could have written this is this way, and it would have meant the same thing. If you have to be, probably if you ask me, this is more readable way. Okay, and this is slightly unpythonic way, that and the readability is kind of compromised over here, right? So always try to write a code in such a way that anybody who is reading should be able to glance and read it in the first go itself. Again a new line, blank new line, again a comment. Now this is my code block over here. If you see, if you are coming from C background, then you will notice that, okay, I have to write for I is equal to like starting from 0 and then semicolon, and then you have to put a parenthesis over here. So that parenthesis represents the code block. Over here, I was saying that not all white spaces are redundant. This is what I meant. The indentation is very important in Python. It doesn't use parenthesis to denote a code block. The code block is represented by indentation, which is white space or tab. I will tell you what it means. So first thing first, if you have to have a code block which is written, let's say you are writing a for loop, and the next code block has to come and you have to put something inside the for loop, it goes with colon. You have to end it with colon. By ending it with colon, the Python interpreter knows that, okay, there is something which is coming, which is within this, okay, within this for loop. Now, when we do this, let me show you quickly how it is done. Let's say if I put enter over here, because Jupyter is such a nice IDE, what it is doing, it is already indenting. It is knowing that I'm doing it after a colon. That means it's a code block, and I should indent it with either a tab or white spaces. Now you can put either tab or a white space The general custom is to put white space, the general tradition or the most of the programmers follow, and they follow 4 white spaces. Now 4 white spaces is not really important or necessary to do. You can do it 3 also, but whatever you do with consistency across the program. That is the only thing which is asked. The general tradition and custom is not to use tab, but to use 1, 2, 3, 4, 4 codes, 4 white spaces, and after that your inner code block will start. Now my inner code block is an if statement again over here. Now if you notice this semicolon over here for if, this semicolon, this is again telling the interpreter, and in this case IDE also, that hey, my next code block is starting. Okay, so it is again indenting it with 4 white spaces, and there is no need of parenthesis. Again, the beauty is that without parenthesis, the indentation with white space itself is ensuring that this code is highly readable. If you notice and appreciate the beauty of it, the for loop, the if statement and the else statement, everything is indented in such a way that anybody who is reading in first glance can make out that what is happening over here. Okay, what we are doing is not actually important over here, right? What is actually important is that how the syntax works in Python. As long as you are getting there, that's fine. Now you can ask that, hey, there is a parenthesis which I'm seeing over here, right? So parenthesis can be used for like probably a couple of reasons, right? One is if we have to evaluate something. In this particular case, we are evaluating that I is less than midpoint. Midpoint as defined as 5. If I is less than midpoint and I is a range. Range is again a method or a function in Python. So this is initiating between 0 to 9 over here. So the for loop will start from 0 to 9. We'll talk about these things later, but the crux of the matter for now is that parenthesis is to define a Boolean expression. It is also used to, let's say, define a method or a function which is given by a particular data type, okay, or an object. So lower is an object over here, and it has a method associated which is append. We'll talk again about it, that this is something which is very different from the other languages, and probably we should try to understand that what it means. Okay, again the print statement over here, starting Python 3, they have started putting a parenthesis which is very much C-like. Again, there is an absence of semicolon, never put the semicolon over here. Now comes the question that how you execute. You execute again by shift return or shift enter, and my 2 lists have been created, the lower list and the upper list. Lower list lists all the numbers between 0 to 4, the upper list between 5 to 9. The code is very self-explanatory. The range is like from 0 to 9. We are just dividing it into two lists, lower and upper. Okay. So friends, the other thing which I wanted to show is this dot operator. So any object in Python, and lower is also an object which is essentially a list, any object, and the method associated with that you can find out in Jupyter by doing a dot and pressing the tab. When you press the tab over here, you will see the list of all the methods or functions which is associated with this particular data type. In case of list, we can see that these are the functions or methods which is available. Now let's see count. So count is a method which counts the number of a particular element in that particular list. So in lower, if I have to count the number of 2's over here, I can just run it, and the answer is 1 because the 2 is occurring only one of the time. Okay, so just to recap this, how you do that is you put the particular variable or an object, and with the dot operator you press a tab sign, and all the list of methods which are available for this particular object type will appear. Okay, so it is very simple in Python, and you do not need to go Google and do lot of help articles, right? Read on Stack Overflow or things like that. The other thing which I wanted to show you is shift tab. So when you do shift tab on any particular object, right, it will list out that what type of object is it. So lower is a list object. It is carrying 0, 1, 2, 3, 4 inside it. and the length is 5. Okay, so you with shift tab you can see that also. Okay, now these were the two important things which we have to keep in mind. These are very useful and very helpful. Okay, the next thing is how multi-line commands work in Python. Okay, how multi-line command works in Python. So let's say you're defining something that 1 plus 2 plus 3 plus 4, and it will go into the next line. How you can do that? How you can go to the next line? The way to do into the next line is you put a escape character, which is a slash, and then start typing 5 plus 5 over here plus 6, right? And you can execute it. Now I have executed, there was no error. Let me put x is 21. This is one way of doing it. The other way of doing it is to put this whole thing in parenthesis and still have it multi-line. Unless the parenthesis is closed, our interpreter will think that it's a one command, it's one line of execution. Okay, again I executed, no error over there. Let me execute, the answer is 21. So that is another way how you can write multi-line commands inside Python. Okay, now what is parenthesis used for over here? I was telling the parenthesis is used for few different contexts inside Python. One context which you have seen is over here, right? If you have a multi-line commands, you can use parenthesis. The other way to use parenthesis is, let's say you are doing an arithmetic operator. Okay, so just like our normal arithmetic, right? We wanted to execute this first and this later, multiplication, then we are doing that. If we do not, if you remove parenthesis over here, what will happen? Like in normal arithmetic, 2 into 3 will be executed first, will be added to 4, but we don't want that. We want it to execute first 3 plus 4, which is 7, and 7 into 2, which is 14. So the answer will be 14. If you remove this parenthesis, what will be the answer? 2 into 3, 6, 6 plus 4, 10. So the answer will become 10. So that is another use case of why parenthesis is used. Sometimes what we do is for a function call. Now, print is an inbuilt function, as we know, right? So if I have to print, this is ML with AP, right? This is ML. I didn't put any semicolon over here, and parenthesis is used to give the input to the function. So for the function call also parenthesis is used. Let me start by an example, right? Let's say I'm defining a list over here. Okay, my list is carrying 4, 3, 2, 1. Okay, this is my list. I executed this. Now let me see that since this is a list, let me do a tab and see that what are the things which are available for this. What are the methods which are available? So I see there should be something called sort. So I did sort. I want this list to be sorted. Now I do not have to pass any parameter over here for sort. Okay, but I need to pass a empty parenthesis over here, right? Just to denote that this is a method, this is a function, and I execute that. Okay, now this, let me just do L over here, and you can see that my initial list was 4, 3, 2, 1. It has been sorted to 1, 2, 3, 4. It has sorted, in place sorting has happened. Now let's move on. Now we'll go to Python semantics, and the way to do, let me put it as a markdown cell. Okay, and I will do the way you convert by a code cell. Default, all the cells are code cells. If you want to make any code cell as markdown cell, easiest way is to do over here through markdown. Or what you can do is you can press escape. You can select that particular code cell. You can press escape and press M for markdown. Escape M, and the cell will be converted into markdown cell. Okay, now let's see that what are the Python semantics. Okay, so first of all, as I was saying, semantics, what is syntax? Syntax is how it is written, the rules, the grammars and all. Semantics, what is the meaning of those words? And so in this particular session, what we are going to cover is the variables and objects. These are the primary ways in which Python stores, references and operate on data. This is what Python semantics will be all about. Now, you may have heard from many people that Python is a dynamically typed language. We'll just try to see that what it means by when we say it is a dynamically typed language. Okay, now let's take an example. Okay, so x is equal to 1. Okay, now if I have to say the type of it, it is saying integer. I didn't define x as an integer, but when I initialize s to 1, Python understood that this is an integer. The type of x is an integer. Now let me change it to 1.2. Let me again do the type. It is a float because I defined a decimal value over here. It is a float variable. The Python understood that now x had changed to a float. Okay. Now let's me do this is ml with ap. Now this is a string, right? This is a string which I have converted it to. Now let me do the type of x. It's a string. Okay, this is what it meant by when people say that Python is a dynamically typed language. If you are coming again from C background and all, in C what we do is we predefine that int I is equal to 5. We initialize, but we define the data type also. Here there is no definition of data type, if you notice, right? What it is storing, it is becoming that, and there is a reason for that, that why it happens like that. Okay, so one of the crucial thing, and this is very, very important, guys, pay attention to it. In C and other languages, when we see x is equal to 1, when we do the assignment, what you are thinking as that in somewhere in the memory, there is a bucket or there is a place where I'm storing 1 and that variable name is x. Inside x, I'm storing 1. Okay, in most of the language. In C, if we define x is equal to 4, here we are allocating memory block to x to store an integer and storing 4 over there. This is what it means. But in Python, x, it works on reference. Okay, let me try to make it very clear. In Python, x is merely a reference to a memory block which is storing 4 or 1 in this particular case. When I say let's x is equal to 1, in that case, in somewhere in the memory block, a 1 is stored. And what is x? X is just referencing that particular memory block. Okay, so it is not storing 1. It is referencing to that part of the memory block which is storing 1. This is a very, very, very crucial difference in how Python and C or other languages differs. And this is why, this is what the reason, the critical reason that why Python is referred as dynamically typed. Because when, let's see what we are doing over here. 1 is stored in a memory block separately. X was a reference to it. So any object tomorrow, if you have to refer X to, okay, I'm referring to a float or referring to a string, my X is just going to refer to another memory block. My x is just referring to another memory block which is storing a float variable. It is referring to another memory block which is storing this is ml with ap, right? X itself is not getting modified. X is merely a reference to a code block which is storing these informations. So the code block which is storing 1 or 1.2 or this is ml with ap, it is as it is in memory. Okay, x is referencing to that location. Okay, I hope this is the very critical thing and this is well understood. Now let's see few more examples to understand that this becomes very, very clear. Okay, now there is a downside as well, that when we are defining variable as merely a pointer, when we are defining variable as merely a pointer to the code block, there is a downside of it as well, right? Let's see what the downside is. If we have two variable names pointing to the same object, then changing one will change the other as well, right? Let's see it with an example to make it clear. Okay, let me define one as 1, 2, 3. It's a list. Okay, I've defined a list. Let me execute it. Now what I did is I have put y is equal to x. Now x is defined as a list Now remember guys that X is not storing 1 to 3. X is merely referencing to the code block which is storing 1 to 3 list. Okay. And again, I'm defining y is equal to x. When I'm defining y is equal to x, that means y is also referring to the same memory location which is storing 1 to 3. Correct? Till this, I hope it is understood. Now let me print x. X is 1 to 3, no problem. Let me print y. Y is also 1 to 3 because y is also referring to the same place in the memory block which is storing 1 to 3. Okay. Now let me do an append. Append is nothing but it inserts towards the end of any list. Okay, so append is a method which is for the list type, data type, and it is appending at the end. Now let me append this. Okay, let me see what is y now. Y has become 1, 2, 3, 4. Okay, now y has become 1, 2, 3, 4. Now what do you think x is now? Let's think for a moment. What will be x? Has x also changed or has x not changed? Now see, x has also changed. Why? Because it's the same memory block. When we, let's go from the top. When we defined x, x is a reference to 1, 2, 3. It's a memory block and x is a reference. We created the same another reference which is y for the same memory block. But what we are appending when we are doing this particular operation, what we are doing is that we are extending this list and appending 4 over there. Now x is still referencing to that, and hence x will also be modified. If you are coming from other programming backgrounds, this will not happen. So this is the downside of it, of having this variable as pointer approach, and you have to be very, very mindful of that. Okay. In case of C, if you have to define x as a variable and y is, if you are changing y, x will retain the value what it was defined at, because primarily x is not a reference in case of C, but x is the actual container where the data is stored. Okay, so this is a subtle but very, very important differentiation, okay, which you should be mindful. Okay, now let's go to another topic over here. Now let's see another example. Here we are defining a is equal to 10. Okay, and we are defining b is equal to a. Okay, no problem. Now let's see. Now let me print a. A is 10. B is also 10. And it is very clear that why it is happening. A is referencing to a memory block which is storing 10. B is the same as A. So B is also referencing to the same memory block as 10. Okay. Now let me do another slight change into this. What I'm writing is a is equal to a plus 5. So what was the value of a? A was 10. I'm adding 5 over here. So a will become 15. Let me print a. A became 15. Now let me do something like, let me ask you this question, that what will be b now? Think for a moment that what will be b now? Will b remain as 10? Will b also become 15? What is b? Let's see the answer. B is still 10. And now I hope by now you got the idea that why B is still 10. If you completely understand that in Python we are only referencing the memory block and not actually storing the data inside the variable, things will become very clear. Let me explain by this example. A is equal to 10. A was referencing the block which is storing 10, or the place where it is storing 10. B is equal to A. B is also referencing to the same block. A is 10, clear. B is 10 is clear. A is equal to A plus 5. What is happening over here? When we are adding, there is another place in the memory which is storing 15. And now A is going to reference to that particular place where 15 is stored. B will keep referencing to the place where 10 is still stored. That's why B is not going to change. A, the value of A has now become 15, which is a different place in memory, which is storing 15. So now A is referring to that particular place, and B is still referencing to 10. I hope by now this is crystal clear, right? Now in Python, we see that everything is an object, and literally everything is an object. Not just the variables, the data types, all the objects. If you think, everything what is defined in Python is an object, right? Even the functions are object, and we'll talk more about it, that why functions are an object, right? Okay, but before that we need to understand something else also, the basic data types. Okay, so what are the basic data types in Python? Okay, so let's see, x is equal to 4. Okay, let's understand what are the basic data types in Python. So there are many, we'll just deal with very few over here, and in subsequent videos we'll go deeper into the more advanced data types. Okay, so like any other language, it has int, it has float, it has a string type. Okay, and we have seen the examples already, I think, of these type, but we can do a type, and we can figure out that what is the, let's say, type B over here. Type B is an int, right? If we have to see something which is x, okay, then the command is type x. Okay, and okay, it's again defined over here, sorry. Okay, let me execute this so that the x is properly reflected. I'm using x as many times, so x is a list, because x is a list over here. So there are list, tuples, sets, dict, int, float, string. These are the primary data types. Let me list it down: int, float, string, which is represented by a straw. Then there is list, there is tuples, and there is dict, and there is set. These are the primary data types available in the Python, right? And probably there are a few more, but these are the basic ones, right? And we already know intuitively what in float and string means. We also know that what list, tuple, and dict and set means, but we are going to deal in the subsequent videos these data types also. Okay. Now, what are the basic operators? So semantics is built not just with variables, but with operators also. What are the basic operators? So the basic operators, let's try to understand it by example. Let's again define it: x is equal to 1, y is equal to 2 to int variable. Now let's see that what are the basic. So you have addition. Sorry, you can do that also, or x plus y. What you have is subtraction. Z, x. Okay, what you have is subtraction. You have multiplication, so x star y, you can multiply. What you have is division, x divided by y, 0.5. What you have, another thing, is floor division. Floor division is something which is, you cuts the decimal parts out. Okay, so let me show you. If I do floor division of y divided by x, it is 2. Okay, yeah, 2 and 1. So floor division is something that you divide into a decimal form, you cut out the decimal, and you keep the lower half, right? So if the number is, let's say, 3.6, the floor division will be 3. If the actual division is 3.6, the floor division will be 3. If we divide two numbers and it is 4.9, the floor division will be 4. So the lower side of the full integer is what is the floor division. Modulo you already know, but let me tell you what the modulus is. Yx. Okay, modulus is 0 for this. Exponentiation is also another thing. So let's say this is how you represent exponentiation, or the power of, this is x raised to the power y. This is how it is raised. Okay, so these are the basic operators which are available. Okay, apart from that, we do have comparison operators also. Now what is comparison operators? Let's say, so y is equal to x, right? If we see y was, what was y? Y was 2 and x is 1. Now y is not equal to x, and it always returns a Boolean value. Boolean is like true or false, it always returns a Boolean value. So whether if y is equal to x, it would have resulted true. Let me just show you. Y is equal to 2 colon x is equal to 2, and then let me execute the same line over here, and it will say true, right? Because now both the things are equal. Okay. Apart from that, it has a less than, greater than. X is less than y. No, it is not, because it is equal. X is less than equal to y. Okay, syntax error. X is less than equal to y. True, because equality is still satisfied over there. So you can also have x is not equal to y, and again it is false because x is equal to y. You can also have greater than equal to. All the symbols will be there. Okay. Now let's go and see that how sometime we can use these operators and these arithmetic operations and these comparison operators. With these two, it becomes very powerful logic. Okay, so if let's say you have to define that something that, okay, you have to find a number which is odd or not, right? So whether 25 or some number is odd or not, you can actually do a modulus, which we already know. If this is equal to, so I'm doing an arithmetic operator over here, and I'm combining it with a comparison operator. And I'm saying that if the modulus of 2 or the remainder of 2 when I divide it by 2 is equal to 1, then that number is odd, and that number is odd. So to find a number which is odd or not, you, in such a concise way, by using the arithmetic operation and the comparison operations, you can figure out that whether the, you can build your logics essentially, that such as and a very concise logic you can build. Okay, and the result of the comparison operator, always remember that it will be Boolean. Okay, now when Boolean is there, then there will be something which is, okay, we have the arithmetic comparisons like equality and all, but what about the Boolean comparisons, like when we are comparing two Boolean values? Let's see that example also. X is equal to 4. Okay, now let me put this x less than 4 and x is greater than 2. Okay, so and is a Boolean operator. And or, if you see the, if you have heard about the logical gates, then and or, not, XOR, XOR, everything is available over here. But and or not, if you are using it, then probably it's okay, and you can get most of the logic out of the Boolean operations also. Okay, so x is less than 4 and x is greater than 2. Now when x is 4, this thing is a false. X is not less than 4. X is greater than 2, true. So there is a false and there is a true. What will be the resultant thing? The resultant thing will become false. So true, false, and true becomes false, right? This is the way the Boolean logic also works, right? So let's take another example. Another example would be x greater than 10, okay, or x modulo 2 is equal to 0. X modulo 2 is equal to 0. Essentially, we are saying that the number is, it will become true when the number is even. Okay, now x is even, so this will become true, right? X is greater than 10, this is clearly false. So this is a false doing an OR operation with the true things. What will be the resulting value? The resulting value will be true, because false or true becomes true. Okay, so this is how you can do the Boolean operations. Now one last thing is that how you do the identity and membership operation. So like and or not, Python also contains some operators to check the identity and memberships. Okay, so what are those? Is, what are those keywords? Is not, in, not in. These are the 4 things which you have to see. Okay, so not in, and these are sorry, these are pretty self-explanatory that what is going, but probably it will become clear with an example. Okay, let's see the example over here. Sorry, let's see the example. Okay, so let me define a set which is A 1 2 3, and we have to define a set B is equal to, again the same thing, 1 2 3. Okay, now let's see A is equal to B, whether this will be true or false. A is equal to B. We can see that A and B are the same, right? So it will become true, right? Now think here, if I write A is B, this is the identity operation. Okay, if A and B are actually identical objects, then only this identity will be true. So in this particular case, they are the value which they are referencing is the same, right? So equality will be true, but are they the same object? No, they are not the same object. So A is B will be false. Okay, and another way to see is the identity of A. If you now this number, this long number shows the individual identity of a particular variable inside, or an object rather, inside Python. So if I see ID of A is this, ID of B, if I have to see, this is this. So if you see the last 2-digit numbers also, they are different. So they are different objects altogether. Okay, they are not the same object, they are different object. They are referencing to a memory block which is storing 1 2 3. This is also storing 1 2 3, but they are separate places in the memory. They are separate, they are contained in the separate block in the memory, these informations, right? So that's why the A equality B is true, but A is B, that is not true. Okay, now let's see another example to make it very, very clear. Okay, now X is equal to, I'm saying 1 2, I'm defining Y is equal to, I'm defining X is equal to Y. Okay, now let me do first operation, X is equal to Y. This we know it will be true, right? Now what about this? X is B, whether this will be true or false. This is going to be true. Sorry, X is Y. This is going to be true, right? Because now X and Y are referring to the same memory block, right? And that's why this identity operation is on. They are the same thing. If you have to do the ID of X over here, this is referring to this, and if the ID of Y, if I have to do, see the last digits, the 952, 952, they are referring to the same object and they have the same identity. Okay, so this is the quick way of checking. These two are the quick way of checking whether we are referring to the same object inside the memory or we are referring to the different block in the memory. Okay, so this is something on the membership, okay, and identity operation. Okay, now let's see one more example of membership operators. So my X is, remember X is 1 2, right, over here. Now 1 in X, is 1 present inside X or not? Yeah, it is present. If I have to say 4 in X, whether X is present inside, 4 is present inside X? No, it is not present. That's why it will come false. So this was the membership operator. I think this brings us to a good solid foundational understanding of what the syntax and semantics mean. Before I leave, I just want to leave you with this. So this is an Easter egg. If you know what an Easter egg is, this is the Easter egg which the Python creators put that inside the Python. And this actually represents the whole philosophy of Python, and how people should learn and work in Python, right? So when you import this is the Zen of Python. And few of the things which you should especially pay attention to, and how the Python creators thought about Python, you can get a sense out of it. If you see over here, readability count, so there is a greater emphasis on readability. Simple is better than complex. Explicit is better than implicit. So if something has to be written down, it's better to write it down in code, in terms of code, rather than implicitly behaving. Complex is better, okay, simple is better than complex. Complex is better than complicated. Flat is better than nested. So they try to do away with the nested operations. And if you can write something in flat, do flat. Readability counts. Special cases aren't special enough to break the rules. So take some time, read it through, and this will give you a very good understanding of how Python is structured also. Okay. With that being said, friends, I think we are I will conclude it over here and see you all in the next video. Till the time, if you like my Python series, please give a thumbs up, share it with your friends, put a comment if you have any questions, and I'll try my best to answer it. Okay. With that being said, bye bye. See you all in next video. Thank you.